Environmental pollution contributed to the deaths of about 9 million people in 2015.
Hello guys, my name is Shankar. I am a leader for Group 30 Marine Pollutions, and today we'll be talking about the instrument used to detect pollution in the water column. Drinking water is continually affected by common problems, including heavy metal and bacteria. This is where fluorescent spectrophotometer become handy. Fluorescent spectrometer has the ability to detect the nutrient contaminations, heavy metal contaminations, and bacterial contamination. Principle of fluorescent spectrometry is based on a Jablonski diagram. When an atom absorbs energy, it becomes excited and moves to the excited stage, and in resting, it will back to the ground and emit radiation, which is called fluorescence. So, this is how fluorescent spectrophotometer works. From the light source, light radiation is emitted and passed to the excitation monochromato, where only specific wavelengths are passed through the sample, which require to excite the sample. The emission radiation passed through emission monochromato and to the detector. The detector sends an electrical signal to readout device. Readout device will be then form a graph, which will be used to analyze the sample. Now, let's go to the next instrument.
Proceed to next instrument ATR-FTIR spectroscopy, which is stands for Attenuate Total Reflectance Fourier Transform Infrared Spectroscopy. This instrument used for the analysis microplastic, which is the size is less than 1 mm. ATR-FTIR spectroscopy measures the infrared region of the electromagnetic radiation spectrum, which has longer wavelength and lower frequency than visible light. So, how does it work? We will start the first step with cooling the FTIR with liquid nitrogen to avoid the infrared lasers overheat the machine. Next, loading the sample into the FTIR. A plexiglass cover used for maintain stable level of humidity and prevents contamination of dust. Third step is background collection, where the system scans the background the particles sit on. Then, a minute later, FTIR will return the background with the spectrum. Last step is sample analysis, which is the sample ready to be analyzed for microplastic. During this step, a visible event survey carried out to get a picture of the area to be analyzed, which is no infrared yet. Then, after the survey done, infrared scan is started. Analysis speed depends on the resolution and number of scans. Next, the scans come back as an absorbent image. Different colors represent potential region of interest. After all, we can then extract the infrared spectrum of desired particles. A book in Polymer Library allows the FTIR to identify thousands of different polymer types.
Assalamualaikum and hi, my name is Fadila binti Muhammad Zarif. In this video, I would like to talk about the Pro DSS Total Algae Phycocyanin Sensor. Total Algae Phycocyanin Sensor can detect chlorophyll A and phycocyanin and are ideal for detecting the freshwater cyanobacteria. Total Algae Phycocyanin Sensor is a dual-channel fluorescent-based sensor. Each sensor can excite two pigments, with a channel for chlorophyll A that can be found in all algae and also with the accessory pigment phycocyanin that commonly found in freshwater blue-green algae. It is used for early detection of blue-green algae that can lead to harmful algae blooms. In this picture, we can see that this is the compartment of this instrument. There is circuit board inside the body of the instrument, and the instrument is covered by the titanium. There is also blue LED with optical filter and orange LED with optical filter, photodetector and also sapphire lens. The channel on the total algae phycocyanin sensor provide result from the blue excitation beam that excite a chlorophyll A molecule, which is from the blue LED, and the result from the orange excitation beam that can excite the phycocyanin accessory pigment, which is from the orange LED. The total algae phycocyanin sensor reports data in the relative fluorescence unit. The source of nutrient that can lead to harmful algae blooms includes sewage, atmospheric deposition, groundwater flow, as well as agriculture and aquaculture runoff and discharge. Eutrophication is one of the several mechanisms that can lead to the increasing of the harmful algae blooms. Phosphorus and nitrogen are the most concerned nutrient source that derived by the human activities. Harmful algae blooms are dangerous threat to public health, the environment, and also economies in the worldwide.
Introduction to GCFID. Gas chromatography is an analytical technique involving the separation of complex mixture of hydrocarbons in oil into component molecular groups. A flame ionization detector, FID, is a sensor that responds to ion release from the combustion of molecules emitting from a GC column as they burn in a hydrogen flame. Lighter molecules pass through the column more quickly than heavier ones, so retention time in the column can be related to molecular weight, and by the introduction of standard individual hydrocarbon can be identified. The fundamental principle is mobile phase and also stationary phase. The type of pollution that can be identified using GCFID is hydrocarbon pollution. So now, let's see how it works.
Hi, today I want to share with you the instrument I choose, which is ICP-MS. So ICP-MS is important to detect the heavy metal. Today I want to summarize how ICP-MS works. The ion source ICP is an ideal ionization source for mass spectrometry and can ionize over 90% of many elements. So it is simultaneous multi-element analysis possible. The ion produced in the ICP are LED throughout the sampling interface to the mass analysis unit. The sampling interface unit consists of two metallic cones. The sampling cone with orifice radius about 0.5 to 1 mm, and the skimmer cone is orifice about radius 0.5 to 1 mm, and a rotary gear pump ventilate between the two into several hundred PA condition. The part of the ion pulled throughout by the sampling and cone and the skimmer cone covers into the ion mass spectrometry. Throughout the ion lens and mass spectrometry ventilate by the turbomolecular pump. The ions sorted by mass with the mass spectrometer are detected by the ion detector. So this is how ICP-MS works. That's all.
Atomic absorption spectrometry, or we can simply call it as AAS. Basically, it is a technique in which free gases atoms absorb electromagnetic radiation at a specific wavelength to produce a corresponding measurable signal. The absorption signal is proportional to the concentration of free gases atoms in the optical path. AAS was developed by a team of Australian chemists led by Sir Alan Walsh in 1950s. There are many types of AAS instruments with specific function like flame AAS and graphite furnace AAS. In marine pollution, this AAS can be used in heavy metal detection like lead, cadmium, zinc, manganese, and nickel. So, how does this thing work? Before that, we have to prepare a series of standard solution, the sample, and the hollow cathode lamps. Firstly, the light emitted from hollow cathode lamp passes through the sample and excites the atom. The atomized sample then passes through the lenses and into monochromator. and then we can detect it with a detector. Usually, the absorption reading is quite small, so we have to amplify the signal using amplifier, and then we can get the absorption as a readout. This is a sensitive technique, and it can be used to measure the concentrations of ions and molecules, even at low levels but with great accuracy. Therefore, this technology is useful in monitoring the presence of heavy metals and trace elements in the water sample from marine environments.